Good evening, everyone. Very good evening. Okay, so let's just start with the class. Okay, so first of all, wishing you a very good evening. It's going to be our eighth session on the same chapter, that is the carboxylic acid, and aldehyde and ketone part. So, let me just give you a quick brief about the previous class. So, in the previous class, we discussed about the naming reaction. There we discussed about the Claisen-Smith reaction and Cannizzaro reaction, benzoin condensation, and Dickman reaction, and yeah, these kind of naming reaction we already covered there. Okay, so basically in today's class we are just going to discuss about only the preparation of the carboxylic acid. Okay, so in the preparation part, or before starting with the preparation part, we are going to discuss about some common name, the important common name of the carboxylic acid. So this one everyone, you know, if you are having this double bond and a COH is there, so the first one is going to be the benzoic acid, like because only one COH is there. In the second one you are having two COH groups, so this is known as a phthalic acid. This is really very much important here. Okay, so it's important part, that phthalic acid. And after this is going to be the cis or butane dioic acid. Maybe you already know from the 12th 11th class. We discussed this topic in the comparison of the acidic strength. Okay, that it's a malic acid when both the CH group is cis to one another. But on the other hand, both the CH group is like trans to one another, so we are end up with the trans product there. So it's a cis and it's a trans part. Now, since as I already told you, it's a part of the 11th class, but can you just tell me, like, if you're observing both the cases, like in this case, the case number one, wait. Okay, so in this case, if you're observing 1OH, 2H, and in this case 1 and 2, like both are the polyprotic or the diprotic acid, you can say. Okay, but now my question to you, like between the first and the second one or the last two, like malic and this, the second one is the fumaric acid. So which one is the strongest acid here? Okay, like malic or like this fumaric one. If I'm talking about the first hydrogen only. Okay, so how to check it about this? So in this case, let's just discuss about this point here, that malic acid and then fumaric one. So if I'm considering the malic one, in this case, this is a common thing, like that is a carbon-carbon double bond. And in this case, this is a CO, NOH is there. And similarly, sorry, cis we are discussing, right? So in this case, this is hydrogen and this is hydrogen, and again this is a carbon double bond O, like this. Okay, so it's a double bond oxygen. It's a double bond oxygen. So in this case, if let's suppose it donate one H positive ion, so how we are end up basically, there is a one negative charge generated. And if you're observing something that the hydrogen and oxygen is there, so what is happening there? There is a intermolecular hydrogen bonding take place. So it's what? It's a intramolecular hydrogen bonding. Okay, intramolecular H bonding simply take place in this case. But on the other hand, if you are observing the fimbric one, there's a carbon-carbon double bond and this is a CH is there. Okay, and this is a CO and O negative simply. So in this case, if you're observing, this OH has no kind of hydrogen bonding like the previous case. Very good evening, Shinu Vasan. How are you? Okay, so this is how we can decide. So be noted that if you are comparing the fumaric acid and the malic acid there, so malic acid, if we are talking about the first hydrogen, so first hydrogen wise, the malic acid is a strong acid, but according to second hydrogen wise, the fumaric one is the stable one. Okay, so let's just back here. If you are comparing the acidic strength of one proton only, so this is more acidic here. Okay, this is more acidic. Anyway, this is all for the common name. Now, as we already covered the preparation part earlier for the ketone and aldehyde, similarly in today's class we are going to discuss about the carboxylic acid. Some method maybe you already know, some of we are going to discuss. Okay, so let's discuss about some method like how to prepare the carboxylic acid from primary alcohol and aldehyde. You have to use a very good oxidizing agent, and definitely we are end up with this. Then from alkyl benzene, and from nitrile and amide part, and from Grignard reagent, from acyl halide, and then some from ester part as well. Okay, so let's discuss all the preparation one by one. So let's discuss about the first one. If I'm having a primary alcohol or aldehyde there, right? So for example, if you are having a primary alcohol is there. So let's suppose if I'm using a very strong oxidizing agent, right? So strong oxidizing agent, like let's suppose you can say it will be KMnO4 or it can be K2Cr2O7. So one time if you undergo the oxidation there, so we are ended with aldehyde, but still if you have to move further as we are using a strong oxidizing agent like a KMnO4, so what we are ended with, that is CH2 and OH is there. So simply this is how we are getting our product there. Okay, so that's it. This is the point number one. Or for example, if let's suppose I'm having a kind of aldehyde, like this is aldehyde, and if already aldehyde is present, then you can use any oxidizing agent again, and then again we are end up with the simply that is the acid there. Oh, I'm sorry, it is going to be the acid. Okay, it's not alcohol. So what we are end up there, again we are end up with a kind of acid there. So simply in both the cases, we are just end up with the acid. So let's take a quick recap as we already covered the main part, like how to proceed. So observe this point here. Look at this. If you're having primary alcohol, if you're using KMnO4 solution, it can be acid, it can be alkaline, or it can be neutral, means every kind of KMnO4 work, okay? With KMnO4, it is impossible kind of task to stop the reaction till aldehyde only. Then if you're using K2Cr2O7, again the carboxylic acid and the zone reagent. Okay, so what is the zone reagent? That is the CrO3 plus H2SO4. But if I am using the CrO3 only, that is the dry CrO3, then in this case we are end up with the aldehyde. Okay, if you remember in the alkyl part we covered about the PCC and all these things. Okay, so just the last case, like if you're not using acid or John reagent, if you're not using, so we are end up with the aldehyde instead of the acid there. Okay, and now let's see the second preparation. So the first preparation is done from alcohol and aldehyde is there. Now let's discuss about the second one, that is from alkyl benzene. Again, it's important. Okay, so many times this reaction we are going to use for the conversion part here. Let's see how. Okay, so let's see that like this is a kind of rule. If the benzene is there, okay, and the CH2 group, let's say connected here, sorry, CH3. So it's what methylbenzene, right? We are discussing about the reaction with the help of a methylbenzene. So in this case, if I'm using KMnO4, so the question will be like every kind of KMnO4. So in this case, basically we are using a alkaline KMnO4. Sometime it will be there like KMnO4 plus KOH. So be noted like alkaline or KMnO4 plus KOH, both is the same thing. So the point is what? Like whatever be the carbon number here, at the end we are simply getting the CH group there. Okay, this is the rule. At the end, simply that is a CH is there. For example, if let's suppose I am using this is a kind of benzene, okay, and this is let's say this is a thing, and the same reagent I'm adding that alkaline KMnO4 in the basic medium. So what we are getting again, that whatever be the CH, okay, like benzene restored. Okay, so in this case, if you're observing this carbon, the conditions would be there like carbon have to be the hydrogen, otherwise it can't go undergo the reaction. And this is again C and CH is there. So what we are end up with there, that is the terminal position, it's going to be the COH and CH. That's it. Any carbon you can take. uh, Cumulative, no, it can reduce Shiva. You know, if you're having a double bond, so we are getting a double bond, like OH group addition there. Okay, so it can, but there the restriction. If, for example, let's suppose if I'm having a, let's discuss about that. If you're having a carbon-carbon double bond, and you know, if you're using a neutral KMnO4 or like the very diluted KMnO4, so in this case, basically you are end up with a diol. Right. So similarly, if you're having a triple bond, so first of all, there is addition of a diol, and then there, that is going to convert in the CO part there. But for example, in this case, the same if I'm using acidic KMnO4, so what we are getting there, that is this double bond break, okay, and then there is a OH bond formation take place, okay. So like this, that the reaction is going to happen. So if triple bond normally, of course it will. Okay, this is the one. Okay, one after this one more session left with the carboxylic. I mean hardly take 5 session, and then biomolecule 2 to 3 session again. Okay. Is this point clear, Shiva? That KMnO4 can be reacted with the triple bond as well. Okay, but you know the like condition decide. If I'm using alkaline KMnO4, then obviously in this case the reaction is not that much good. But if I'm using acidic part, then reaction can be there. Okay, Shiva. So let's back what we're discussing again. For example, if let's suppose I'm having a triple, this is a benzene. Okay, and this is a carbon and it is connected with CH and hydrogen. So again, that important part, this carbon have to be the hydrogen. So let me just use one more. If CH3, CH3 and hydrogen. So in both the cases, same reagent you have to use, and at the end we are end up with the benzoic acid. Okay, but on if let's suppose I'm highlighting here. If let's suppose I'm using this is a carbon and it is connected with three more carbon. So in this case, the terminal, the center carbon, let me highlight this. So this does not have any kind of hydrogen. It means this is not going to participate in a reaction. No. Okay, so this is how you're going to check simply about the Cheminov reaction. Okay, so let's continue further. This is very simple reaction and mechanism important notes. Mechanism is not really important. So let's see that what we just discussed now. Yeah, look at this. So in this case, what is the basic condition? What must have at least one hydrogen, at least one, and acidic alkaline KMnO4 or even KRO3 you can use as well. And then hydrolysis and a CO2 and we are end up with the CH is there. Most of the time we are using alkaline KOH. Okay, acid you can use. Uh, Acid is not the issue because see we are using carboxylic acid here. But if for example, if let's suppose the condition be like, let me highlight to you. For example, let's suppose I'm having a carbon-carbon double bond, okay, and then let's say this is a CH3 there, and in the same one, if I'm using the acidic KMnO4, so definitely it is going to break the double bond from here. So the rule that the preparation from alkyl benzene, so benzene have to be there, okay. So this is the rule that only benzene CH3 is going to participate in a CH formation. Otherwise, like as you already asked Shiva, if you're using a double bond or triple bond, so KMnO4 prefer that double bond or triple bond instead of that CH3 part. Okay, so this rule is only for benzylic hydrogen. Okay, that's it. Let's see, like we already covered one carbon, like three hydrogen, and in this case there is a one hydrogen, in this case zero hydrogen. So obviously it's not going to participate. We are just end up with the carboxylic acid only. Okay, this is the simple reaction of the benzylic. Wait, where's the chart? Okay, so this part is covered, that is from alkyl benzene. Now let's talk about from nitrile and amide part. Okay, so here technically we are just dealing with the kind of reaction there. So let's discuss about this like how. So look at this. Okay, wait, that is the KMnO4 slide. If you have to use the acidic KMnO4, so I already told you that if you're using a acidic KMnO4, so it's going to break from here and we are end with the carboxylic acid and carboxylic acid. Now let's talk about from the nitrile part here. Okay, so this is really important. Maybe it's not look very important here, but it's really important for the amine chapter. If I am using RCN, and if let's suppose we undergo that is the mild. Not the slide. Okay, here, just come here. So in this case, what is written there? If you're using a mild condition, first read the statement. If you're using a mild condition, the reaction stop till amide stays only. Okay. If in the same reaction I'm using mild hydrolysis, or you can say partial hydrolysis, that this is the good point. That is a partial hydrolysis. Okay, so in this case, let's suppose I'm using a partial hydrolysis like this. So first of all, the CN part is going to convert into the amide. And then further, if you undergo the hydrolysis one more time, at the end we are end up with acid. So it's not like that is a reaction can't stop here, or it's not like that every time we are end up with this. Not totally the situation. If you're using mild hydrolysis or the partial hydrolysis, definitely we are end up with amide. Otherwise, with full, okay, let me just write fully hydrolysis, like fully hydrolysis. So in this case, at the end we are end up with the acid. It's really very much important part for the mind part. Again, in this case, mechanism is important. No, mechanism is again not very important here. So for which, like then mechanism is important. We already covered the naming part. Okay, so look at this first amide followed by that acid. Okay, which and NH2 and NH3 and like this. Now let's cover some important part. If you remember this in this case, like as you already know the mechanism, but let me tell you the mechanism one more time. So if let's suppose you will be using some R, okay, this is R and this is a CO, and wait, what was that? No, COH, okay, aldehyde. So in this case, if I'm using aldehyde, and let's suppose what we are using it, that KCN, right? So if we are using KCN and H2SO4 there, so in this case, the same type of mechanism we already covered in the benzoin, if you remember, okay? I guess so many days, so maybe you already forgot. But anyway, so in this case, this is a CN negative. It's simply attack here, okay? And this is how the bond open up. So basically, what we are end up, that is a R. This bond open O negative and hydrogen, and then CN is there. Okay. Further, if it undergo hydrolysis there. Okay. So what is happening? That OH is going to abstract the hydrogen from here. So in this case, if you are observing, we are end up with this O and CN there, and this is known as a hydrocyanine. Okay, like the common name, general name, hydrocyanine. Like means in this case, one OH part connected and one is the CN part connected. Okay, if you remember this part we already covered in the that acetyl and ketyl part. Okay, so this is the case. Look at this, that one portion become O and then CN is there. Okay, well, let's back here. And further, if you have to undergo the hydrolysis, so CN, as we discussed, if you have to undergo with the like hydrolysis, sometime ma'am, how we know like strong hydrolysis or not? If del is there, this symbol represent that reaction is vigorous. Okay, if I'm using the del symbol with water, so definitely the final answer is going to be the COH there simply. Okay, so this is how you can decide. Now let's see the last part, that is from Grignard reagent. Okay, or like which whatever the method. Okay, fourth method from the Grignard reagent. Again, Grignard reagent we already know. Let's just quickly discuss about the mechanism. If I am using RZMX and plus CO2 gases there, right? So in this case, that R has a partial positive charge, magnesium has a partial negative charge. So in this case, this positive will simply attack here. Okay, that this R positive simply attack here on the CO and this bond open up. So this is a CO negative and double bond will remain same and R group simply connected here. Since this is negatively charged, so MgX part also connected here, and then you have to undergo hydrolysis, and then we are end up with the CO which is there. So this conversion is important if you want one extra carbon. One extra carbon be like that we are just starting with the R, but now with the R, we are getting extra carbon as well. So with the help of Grignard reagent, if you have to form the acid, so the extra carbon generated there. Okay, so this is how the reaction with Grignard reagent. So let's just back what we're discussing. So that's it. This is all for the case. Now let's discuss about the acyl halide and anhydride part here. Okay, so acyl chloride part again. Now the mechanism seem very easy because we already discussed very scary kind of mechanism. So what is acyl halide? So what is the meaning of this word acyl halide? That you can use any halogen, but most of the time we can use chlorine. Okay, in this case, that does a method can be different. First of all, that the same method you can follow, that you can use the basic hydrolysis. Okay, or you can use the acidic hydrolysis. Maybe this question came in your mind, and what is the difference between these two hydrolysis? So simple that it is be like OH negative and then water. Okay, it's written like this. So it's a basic hydrolysis. But on the other hand, if it's written like H3O positive, so it's definite. Like we are using some acid plus water, and this is how we can use that this part here. So in both the cases, the final product is definitely going to be the acid. But what is the difference between them? A very small difference. So what is the difference? In this case, if you are using acidic hydrolysis, so like directly we are end up with the acid. Okay, so you have to just started with this and we are end up with the acid. But in this case there is an extra point. What is the extra point? First of all, we are getting CO negative. Okay, and then in this case you have to again add some water or undergo the hydrolysis, and then there is a formation of acid. So this is the extra step. Okay, sometime maybe it ask in a statement. Okay, like if you are using basic part, so we are end with the carboxylate ion first. So this is important, like with base carboxylate ion formation first, and for the acid part direct CH formation is there. Okay, even you can like observe how, for example, if I'm using a base, so this is a CO and then Cl is there, right? And in this case, I'm using O negative. So then, this is a behaving like electrophile, sorry, nucleophile, and we are getting our CO and then Cl and then OH is there, right? Simply this is how the case there. And in this case, that O negative generated here. So be noted that in case of basic condition, carboxylate, and then there is a formation of this thing. Okay, that's it. And one more method, anhydride, right? So again, that you can undergo the same part with the anhydride, that are CO and O and a CO and then R is there. So in this case, same, you can use basic hydrolysis, or you can use acidic hydrolysis as well. Okay, wait, I have to use the water. Okay, so acidic hydrolysis as well. So in the same, like if you're using anhydride as well, same in this case, you are getting that COH and one more, that in this case, COH, oh sorry, I miss again, that is the carboxylate ion there. Okay, let's see an example here. For example, if let's suppose I am using this. Okay, this is a Cu and CH3 there. So in this case, if I'm using water, like it's not an issue. Like both cases same. If maybe the bond break here, so the OH negative and add here and the H positive here, because just because of the bond, this got the partial positive charge and this one the partial negative because that is oxygen. Or maybe the second criteria, that no, we are not going to break the bond from here. Maybe the bond breaking from this position. Okay, so this same, that H positive may be attack here or OH here. Means the main agenda is what in both the cases we are end up with the acid only. Okay, so it means that the final answer is going to be two acid formation is there. So first of all COH, and then this becomes CH3COH is there. So this is how we are end up with a different kind of acid. Okay, look at this. That's it. This is the only thing we have to identify. And again, mechanism is not really very much important here. So now, your turn. Any problem with any point? Okay, so just simple reaction is going on. Okay, so if still any problem you are having, so let me know. Now, otherwise, let's solve some questions. Okay, so that we can discuss about. Okay, let's discuss the last one, ester. Then we are going to solve the question. So now let's discuss about the ester part here from ester. So same, you can go with the ester. Okay, so for the ester part again, that if you are using a kind of ester RCOR and the same point, that is the basic hydrolysis you can go, or the acidic hydrolysis you can use. So same in this case, you are under with the RCO negative, and in this case, we are under with the COH is there. Okay. And one more product, alcohol is there, right? ROH is a complement because when it's breaking from here, so ROH, ROH. Like in the previous one, we are getting two kind of carboxylic acid. Like in this case, two molecule of this and two molecule of this. So similarly, in this case, one is the alcohol and one is the RCH is there. And if you are observing here, where was the reaction? Yes. So in this case, that if I'm using HCl as well, okay, means HCl is the product. And for this reaction, there's an important note as well, that in this reaction we have to use pyridine. Okay, so this is a kind of note. If we use pyridine, okay, I hope you know the meaning of the pyridine. This is how the pyridine look like. Okay, so in this case, what is the case? That pyridine has a lone pair, right? So it's a very good base. So it start consuming the HCl. So if it is reacted with the HCl, what is happening, that there is a formation of this pyridinium salt there. Okay, like now nitrogen got the positive and chlorine be like this, pyridium chloride, and this is how be like, for example, that we are moving from reactant to product. Okay, so in this case, if you're using pyridine, so it start consuming HCl. It means we're like basically consuming the product side. And this reaction is an equilibrium condition. So according to the Lee-Chatelier principle, reaction follow the forward rate. Okay, so like reaction followed the forward direction and the rate of reaction increases there. So do you know, out of all the step, if we are using our COCl for the preparation of carboxylic acid, so it's a very you can say most commonly used step, and yield is also very good for this reaction. So that's it, this is all for the preparation. Okay, so let me quickly brief you. We're discussing about the preparation of the carboxylic acid from, first of all, from alcohol we're using any oxidizing agent. Second of all, methyl benzene, that alkaline cheminophore we're using. And then acyl chloride, ester or anhydride. In both all three cases we can use just acid only. Now it's time to solve some questions, and please, it's a request to everyone that you have to solve the questions. Okay, so we are given with this compound, and it's a JEE main question, not advanced question. Okay, this is a question. So like, this is a product. Okay, let me just write down. So you are having some kind of reactant. Okay, in the reactant I'm using NaOH, and we are getting this is a product there. So basically you have to identify the reactant. Okay, in this question, that question is what? That you have to identify the reactant. Identify the R. Okay, so like reactant, what is the value for R? So there's some option for you. Option number one, like that in this case, CO, CH3 we're using, or the COH is there. This is the reactant number one. Miss you to start it with this. And the point number two, that you have to use CHO and a acid there. And three, and more than one option can be correct here. Okay, I know this is a main question, but still in this question, possibility of two option may be there. Okay, so be noted. Now option number D, like four, right? Yes, please. It's a CHO and a CHO. So from where you to start so that we are under with the final product. And take your time. Okay, 2 minute. 2 minute is more. 1.5, okay, means 1.5 minute. And solve this, please. Let me just remove. I hope it's visible clearly now. So from where you to start? Yes, anyone? You're solving? Last 30 seconds left. One and three. Okay. Okay, so let's start that how. Okay. So let's continue with the question. Okay then. So let's discuss about the question. So in this case, that let's start with every option, okay? Because I'm explaining the question to you. So first of all, I'm starting with this. Okay, the option number one. So in this case, you will be having a CO and OCH3 and then COH is there. So we are using NaOH. And which kind of NaOH? This is concentrated NaOH, right? So like concentrated NaOH we are using. NaOH has a one possibility. The possibility number one, OH be like I am OH negative ion. Okay, so I want H positive ion. So in this case, there is any single like H positive ion present. You know what is the acidic proton? If let's suppose this is my CO group, so this can be acidic or this can be acidic, or maybe that directly if OH group is there. But in this case, not even a single possibility is there. So the condition number, okay, Niharika. So, like condition number one is fail there. Okay, it is not going to be the answer. Okay, so now the second possibility. Now recall all the naming reaction. You know that it's not like naming reaction, ma'am, teaches and okay, that done. No, think about it. If I am using NaOH, which kind of NaOH? N concentrated NaOH. So there is a one possibility, like aldol condensation can be there. No, that is what for the diluted one. So which kind of reaction we can go? That is Cannizzaro reaction, if you remember. Cannizzaro reaction, right? So Cannizzaro reaction, that Cannizzaro reaction is the only reaction which work for concentrated NH plus 0 alpha hydrogen. Right? In this case, if you are observing, both condition is fulfilled, that 0 alpha hydrogen, okay? Or like Cannizzaro reaction may be there. And now you will tell me, Shiva, or like everyone, that is there any scope for the Cannizzaro reaction? Really? This is how you to analyze the question. It's not like, yes, please, anyone. What do you think about it? So, answer is no. Because Cannizzaro, what is the Cannizzaro reaction? That we have to start with some carboxylic, sorry, aldehyde or a ketone there. Ketone is not the scope because alpha hydrogen is always present. Okay, it's not. No, it's no. It's no. Okay, we know that only one thing is going to work there. That which one? That maybe this or maybe this, that aldehyde with zero alpha hydrogen, if you remember, right? So in this case, first of all, ester, okay, the only reaction which is going to participate in for the ester is what? That if you remember, one is the Perkin reaction or the Dechmann reaction, two reaction there. But the possibility, if you remember with the ester, you have to use CH3CO negative, so again it can't be there. So means one option number one can't be the answer with NaOH because NaOH is mentioned. Otherwise, you can use any possible case. So I hope the point number one is clear, that A is not going to be the correct answer. Okay. So let me just remove the option number one. Now let's go with the option number two. Okay. So let's discuss about the option number two. So for the option number two, that OH we are having, right, or aldehyde. Let me just remove this. Okay, now same NH we are using. So maybe this time we are having a scope of the like Cannizzaro reaction. Why there is a scope? Definitely because in this case aldehyde there, aldehyde is present there. So what is Cannizzaro reaction, if you remember? Cannizzaro is the reaction where either the, you know, oxidation is there or reduction is there, both kind of reaction. Let me just quickly give you the brief, that for example, if let's suppose I'm starting with formaldehyde and I am using concentrated NaOH. So one product we are end up with the salt, if you remember. Okay, and one product we are end up with the alcohol, right? That OH is there. We already covered the mechanism in every part there. So that's it. So it means that if I have to start with the option number one, acid and this aldehyde, so this acid will like, no, I can't react. Okay, you have to react only. So if we can go with the Cannizzaro reaction, so only this thing is going to participate. Okay, so the condition number one. Let me just write both the possible product. Okay, I'm erasing this now. So in this case, if you have to go with the Cannizzaro reaction, okay. So what is the point number one? That this will remain same COH. That maybe we are getting CO negative plus. You know, there's a two kind possibility of two kind of product. Or the product number two, that is the CO, which it will remain same, and this is a CH2 and OH. Right? Sorted. This is the thing. Maybe we are getting. Okay. Now in this case, can you just tell me that, let's just back. What is this? It's a kind of lecton. If you don't know, it's a kind of lecton. So let's see actually how it is going to work. Uh, let's suppose, okay, I'm having one carbon, CH2, and this is a CO, and okay, this is a CH3, and this is a CH2, and this is a CO, and let's say this is the CH3. Okay, so how it is formed? Just try to understand. So in this case, that if let's suppose that this carbon has a proton, so the ones 1, 2, 3, 4, 5, so it attack here. So the possibility number one, we are getting a five-member ring, kind of. Okay, let me just write the carbon. One carbon, two carbon, three carbon, four carbon. And here we're dealing with the aldyl condensation. Just try to understand what I want to explain just simply. Okay, so the carbon one attack here, and the carbon number two, there is a O there, O negative, and a carbon number five, that O negative generated, like OH. This is a simple aldyl condensation, and then it's removed, and then there is a formation of double bond here. The possibility number one, or maybe the possibility number two, that in this case, that if let's suppose we are not using any base, we are not using even a single base, okay, no base is there. In this case, if I'm using dilute NaOH like this, so in this case, the possibility number two is what? That maybe this oxygen has a lone pair, So oxygen be like, not an issue. Why not I can attack on a carbon? So maybe this oxygen attack here, and this is how the bond open up. Okay. So if you to count the number of atom now, so the numbering is starting from 1, 2, 3, 4, and 5, right? So if 5 is there, so what we are end up again, that it's a 5 member ring, definitely oxygen, it's starting from oxygen. So it's a carbon number 1 and a carbon number 2, carbon number 3, carbon number 4, carbon number 5. Okay, 5, there is a double bond, and it like bond open up, so it's a O, and CS3 group is also connected here. And okay, now this is how we are end up. Okay, so look at this. So this is how the oxygen bond joined with one another. Okay, so maybe this can be the case. Or the second condition, if you remember everyone, that if let's suppose I'm having a acid, okay, or some R which is there. Remember, everyone, you remember this thing? If you're using alcohol plus acid, esterification have to be there. So it means that CO R. Okay, so what is it? Ester formation. So let's just back again. The question is there. So isn't it a kind of cyclic ester? Okay, just focus on this part only. Okay, it's a kind of cyclic ester. There's a ring is simply closed there. It means we want at least one alcohol and one acid. Right? So this is the main point, like how there's a possibility of lactone formation is there. So let's just back here. So isn't it we are having a kind of alcohol and acid? Maybe it can work. Maybe you are able to form ester, and definitely it is going to be the case. Okay, so in this case, that this product is not going to participate further because both are the acid, but it can be work. And after this, that oxygen has a lone pair. Okay, so oxygen simply attack here, and this is how the bond open up. Okay, so let me just explain this. Otherwise, you can simply form the electron. It's not like shortcut as well there. I will tell you the shortcut. Wait for a while. And this is how the bond open up, and this is my OH group, and there is a 5 member ring formation is there, and oxygen is there simply. Okay, if you are not getting how there is a 5 member ring, every time use the number there. So it's starting from one carbon, like one atom, two atom, three atom, four atom, and five total. It's a 5 member ring. Okay, so my numbering be like it's a one, two, three, four, and five. Sorted. This is the case number one. And in this case, the second case is what? That further, in this case, look at this. This oxygen is there, and this undergo hydrolysis further and leave the molecule simply. So means at the end, we are end up with this is a six member ring, and it is connected with like this and a double bond here. So this is how we are getting our product. Okay, so it means one point is very clear, that you have to use a kind of acid. So let's start that, where we're starting, that option number two. So let's just back to the question. So option two can be the answer. Okay, because one is acid, one is aldehyde. In this case, again, both are acid. That for the Cannizzaro reaction, how to be work, that we are using at least one aldehyde. So the option two is sorted. And see, option number four, both are aldehyde. So it can be work here as well. Okay, because again, okay, let me just explain this point to you as well. How? So for example, that in this case again, this time we are having a 2CH group, right? So it's a 2CH group there. So then what is going to happen? It's in this case again, if I'm using concentrated NaOH, so Cannizzaro reaction. So one aldehyde be like, I am converting into the acid, and the one aldehyde be like, I am converting into the alcohol is there. So the same reaction, Cannizzaro reaction. Okay, don't say, ma'am, that maybe both converting the alcohol or both converting the acid. So again, we have to use the major product only. So this is the major. Again, the alcohol will simply attack here, this bond open up, and the same electron formation is there. So hence, for this question, the answer is going to be the maybe this option, or maybe like second and fourth is the correct answer. Okay, actually, this reaction only simply checking the basic knowledge. If you know the Cannizzaro reaction very well, so directly, indirectly, you are able to mark the correct answer. That aldehyde have to be there. So maybe the option number two can be there, or maybe the option four can be there. Okay, any issue with the question? Okay, so Niharika, you are right for the two. And is this point clear, Shiva? Why not one and three is the answer? Because acid can't undergo the Cannizzaro reaction. Okay, if you want ester, at least one alcohol have to be there. Okay, this is the question number one. I hope it is clear for everyone. And it's your turn now. If you're not getting, please let me know. Okay, let's see one more question. This time the simple one, not very difficult. Why I'm using these kind of questions so that we can discuss the basic thing, how to solve the question from the organic chemistry. So again, this is a question. Okay, so first of all, you have to tell me which kind of reaction we are going to use here. Okay, then we have to move further. So this and the reason number one we are using, this is a formic acid, sorry, formaldehyde, and then excess of this we are using. Okay, this is the excess there, and then NaOH and then heat. Okay, just let me know the name of the reaction if you know. And the second step, this is a HCHO and H positive and catalytic amount. Yes, please. First of all, what is the name of the reaction? Of course, I will. Wait, Dishika. So, in this case, what is the point number one? Let's suppose if I am using a acid or a aldehyde. So, if you have to undergo the Cannizzaro reaction, what is the Cannizzaro reaction? The same thing undergo hydrolysis, give as that is the acid as well as alcohol, means one part undergo reduction, one part undergo oxidation there. It is not going to participate in a Cannizzaro reaction because the condition for the Cannizzaro reaction, aldehyde have to be there, the point number one, and plus zero alpha hydrogen have to be there. Okay, and then if in this case I'm using concentrated NaOH, so what we are end up there, that the acid will remain same. Okay, acid will remain same, and this part undergo maybe the alcohol plus, you know what is Cannizzaro reaction, from there to there, it's a reduction there. Or the point number two, or the product number two, that if this is a benzene, okay, this is a COH and this is a C OH is there. Okay, like both are the COH is there. Means from there to there, it's a oxidation. So this is a Cannizzaro reaction. Okay, and after this, for this product, we are going to move further. Like if this is a benzene and this is our COH and it is a COH and H. So in this case, what is happening? Water molecule is going to remove. Okay, it means simply water molecule release there and they are forming a ester. So it's a CO, oxygen and CH2 and done. Okay, or you can use like same here, that aldehyde as well. So in both the cases, if I'm using, this is a CH2 as well and this is a CH2 as well. So both product give the same kind of reaction, Cannizzaro reaction. Okay, is this point clear now, Dashika? Actually, how to solve the question? Yes, Dashika, please confirm. Are you getting or not? Okay, I hope you're getting. So let's just back again what we're discussing, right? This question, okay? So in this case, we're using, and you have to identify the product definitely. So what will be the product? Option number A, okay? Why I'm using this question? Because this question is going to cover so many concepts of the previous classes. That's why, so that we can quickly revise the thing. Okay, this option number A and option number B. Some of you will be like, what is this weird structure? Let's leave the question, okay? You know, this is the problem in the paper. First of all, the option is that much scary that we are not going to approach these kind of questions. B, option number B, okay, option number C. Actually, it's a one of the famous reaction for the protection there. Okay, I will tell you how. This is option C and option D. Again, take your time and just try to analyze. If you're not getting the question, don't worry. I'm not assuming like you are able to solve the question. Okay, I just want to check something that you are able to detect the naming reaction here or not. Yes, please. Can you just tell me the name of a reaction? CHO is there and Cu group is also present there and excess of NaOH and heating we are using. Okay, excess of NaOH, excess of HCHO representing us that we can use as much as aldehyde we want. Okay, it means one step, two step, three step, any step you can use. And one more thing, it's not mentioned like we have to use as concentrated or like diluted one. So it's written normally NaOH, so you can assume anything. Okay. Yes, please, can you just tell me the name of the reaction if you know? Options are aldol condensation or Kenny-Zaro reaction. Now, please. And I'm asking with the reference of this, okay? This, let's suppose this is some product number, A reactant number in reactant number B. Okay, otherwise, then you're going to say, ma'am, with respect to the HCHO, Kenny-Zaro, and with respect to this aldol condensation, okay? So I'm asking between A and B only, right? Okay. So listen, my point, it is going to be the aldol condensation, the step number one. So, what we are using there, it's simply benzene and it is connected with, let me just check, double bond, okay, like this. So in this case, we are using NaOH, right? So that with NaOH, two kind of reaction again, the Cannizzaro or the aldol condensation. So it's not mentioned like concentrated we have to use or like which kind of COH, NaOH we are using. So we can apply both the condition. So in this case, if you're observing something, that CO group and this carbon is alpha. So there's any alpha hydrogen present? Yeah. If alpha hydrogen present, so there is a scope for the aldol condensation. So this is alpha hydrogen. So simply OH abstract the hydrogen, and what we are end up there, we are end up with the formation of carbon anion, right? And then we are having a formaldehyde. So what will be the next step there? Simply that this O negative simply attack here. Sorry, aldehyde. Okay, so what is the next step there? That simply this bond break, and this is how the bond open up. Simply aldol condensation is going to be there. So it's benzene again, and this is a CO, and this carbon. Okay, this carbon already connected with two CH3 group, and now one more. This is connected with this CO which is there, right? So this is the simple thing we are getting here. COH and then RCHO. Point number one, let me just write in a decent way actually how it's look like. Okay, this is the point number one. And again, since we are using excess of NaOH, right? Next again, if I'm using again the NaOH is there. So the next question again, there's any scope of the that which one? Aldol condensation? So no. Why there is a no? Because again, this time with respect to the CO group, there's a no alpha zone because now this carbon is already connected with four different group. Okay, so it's not going to participate again. So the point number two again, that NH is there, CHO is there. So let's go with the Cannizzaro. Which kind of Cannizzaro? Cross Cannizzaro reaction. Okay, cross Cannizzaro reaction. So what is the cross Cannizzaro reaction? If you are having two kind of aldehyde and both with the zero alpha hydrogen, like in this case no alpha hydrogen, in this case just focus on this portion only. Okay, that one is not the topic of discussion right now, only the CO group. Okay, only the CO group, and this is a CHO group. And if you remember the rule there, that how to decide which one is going to be the acid or which one is going to be the salt there. Look at this. In this case, this is less electron withdrawing group. So it undergo like CH formation. So in this case, CH is there, and this one undergo reduction part. Focus, I will highlight like about the chains, and it is a CH3 and it is a CH3. Okay. So like what is the change here? If you to observe that this CO group, okay, this CO group simply converted in the CHO group there. Normal cross cannibalization is going to happen, and you can write it's a salt like O negative, Na positive. So this is a cross Cannizzaro. Now again, since we're using excess of CHO there, so till we are having a choice, we can go further. So let's go. So in this case again, this is a benzene. Now here CH2, here OH group is connected, right? And again OH group is connected, right? So this is the thing we're getting, like that thing. And now in this case again, if you're using aldehyde, okay, so enough with the CHs there. Now we, if you're observing something, that here we're using catalytic amount. Okay, after this, let's just back to the question. Where's the question? This is the question. So step number one is done. Okay, and which part is done? Now let's focus on the step number two. Again, that we are using CHO and H positive and then catalytic amount. Okay, so let's see that how it is going to work now. So again, if you're using acid part here, so acid be like this is going to combine with H positive. This is just increasing the rate of reaction. Nothing is happening. Okay, so in this case, this OH be like I'm having lone pair, this OH be like I'm having lone pair. So both can be there. Let's suppose first of all this CH group simply attack here. This is how the bond open up. Again, mechanism is not important. I will tell you the trick how to go. Just try to understand. Then at the end we are going to discover the shortcut as well. So this is how that this OH will remain intact. Okay, and this O simply combine with this COH and hydrogen is there. Okay, and then these two molecule, there is a formation of water take place. Let me write here. This same product, okay, I just explaining the thing only. So it's a O, H, this is O and H. And then from there to there, water molecule remove. Wait, I have to miss oxygen here, right? So if you have to remove the water molecule, we are in with this. Okay, this is the final product. If you have to observe something, that have to follow the option A is the correct here. Okay, but now let's see how to follow the normal step normally. So after the first step, that aldol and then canizaro part, at least you have to go, right? This is the thing we are having, and this is a COH, and this is a COH is there. And then we're having formaldehyde. So let's just write it's be like CO and hydrogen and hydrogen. So in this process simply, that this side combine water formation and this side combine. So you can say that C group is going to fit between this. I'm explaining this part only. So observe, sorry, it's a O, it is connected with O, and there is a C group is fitting there. Okay, so this is how the final product. It's nothing, it's known as a, if you are having a two diol. Which kind of diol? Let me just give the numbering. One carbon, two carbon, three carbon. Observe this. It's a one carbon, two carbon, three carbon. So if you are having 1,3 diol, if you are having 1,3 diol, yes, we have to use HCHO as a protection, protecting the group, for protecting the group. And how about the protection? That this is how the protection take place. That the CHO group simply convert into this. Okay, that's it. This is how the option is the correct here. Let me again brief the complete question for you. That first of all, we have to undergo the aldol condensation. No, this is not the question. Yeah, here. So first of all, we have to undergo the aldol condensation part, and then after that, we are going to undergo the Cannizzaro, cross Cannizzaro. Okay, let me just write aldol condensation. Okay, then cross Cannizzaro, and then the last step is this, that protection part. Okay, so I know question is a little bit lengthy, but yes, Shiva, you was right. That is a cross Cannizzaro. Five carbon is there. I miss some carbon. Okay, anyway, I'm sorry for this. Actually, I have a problem with the number. That's why I used to write numbering. So it's a one carbon, two carbon, three carbon, four carbon. I'm missing five carbon. One, two, three, four. One, two, three. Yes. Where five carbon? Anyway, okay, if I miss some carbon, please check this. Because right now, according to me, every carbon is okay. It's one, two, three, four, and five. 1, 2, 3, and 4 and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Okay, got it. This would be which, right? Dashika? Okay, so this is how we are getting. Maybe I increase some carbon. So this is oxygen, oxygen, and like this. Okay, I hope it's clear now. Okay, so that's it. This is all for the question. And let me just check. Okay, so we are done with the basic reaction there. Okay, in the next class, we are just discuss about the last part of the carboxylic acid. Okay, we're just left with small portion. That's it. This is all for the class. Now you're done. Any problem or any doubt? And again, please keep revising the question. Solve more question, and that's it. Yes, please. Any doubt? Any problem? And from today onward, we are going to take the. I'm going to take the classes regularly. So it's a request to everyone. Please try to join the classes. Okay, be on time and again, so that we can finish the syllabus till 20 November, 20th of November, and then you will be free from my end. So thank you then. Thanks for joining the class. Have a nice day, everyone. Thank you.